Let's look at some basic tools to solve equations. But first of all, what exactly is an equation? If we look at the word equation, it begins with EQUA. Can you think of any other words that begin that way? Well, you might think of the word equal, because an equation has to have an equal sign. Oftentimes students mix up equations and expressions. If I write 2x plus 5, is this an equation or an expression? Notice that what we've just written does not have an equal sign, so it's an expression. To make it an equation, we need an equal sign. So if I were to write 2x plus 5, and of course if there's an equal sign, it has to be equal to something. So if I write 2x plus 5 equals 9, then now this is an equation. If we write 3x plus 4, this is not an equation. But if I write this is an expression. But if I write 3x plus 4 equals negative 19, now it's an equation. Or even if we write y equals mx plus b, we have an expression on this side. What I've just underlined in blue is an expression. And we have an expression on the other side. What I've just underlined in red is an expression. This expression on the left has one term, or is one term. And this expression, because there are two things that we're adding here, has two terms. So put together like this with an equal sign in the middle is an equation. So this is an equation with a two-term expression on one side and a one-term expression on the other. Let's get familiar with some of the terms that we might see, some of the vocabulary that we might see or hear as it comes to solving equations. So we might be asked to find the value of a variable. Basically, what is the solution of the equation? In other words, what value or what amount makes it true? So a value is just another word for an amount. We might hear equivalent equations. So as an example, if we have the equation 2x plus 1 equals 7, and we compare that with the equation 2x equals 6, and we think about what could we put in place of either of these to make them true. If we put a 3 here, 2 times 3 is equal to 6. In other words, 2 times 3 is 6. This would have the same value as what we have here, so it would be true. So if we put a 3 here, 2 times 3 is 6. So yes, 3 works here. We could put a 3 here and it makes sense. Up at the top, if we put a 3 here, 2 times 3 is 6. 6 plus 1 is 7. So if we erase the x and put 3 here, it would also work. So in other words, 3 works for both equations. So for the equation 2x plus 1 equals 7, and for the equation 2x equals 6, they have the same solution. They have the same value of x that make them true. We could put the same number where the x is and end up with the same answer. So that means that we're dealing with equivalent or equal equations. When we're solving equations, this is what we want to happen. The way that we do that is we use what are called inverse operations to do that. And basically, inverse operations are just opposite operations. So for example, if an individual adds $3 to the amount that they have, and then the following day they spend $3, then they end up back where they started. I could put any number here and this would be a true statement. So in other words, let's say we put a 7 here. 7 plus 3 is 10. 10 take away 3 brings us back to 7. If I put a 9 here instead, 9 plus 3 is 12. 12 take away 3 is 9. So we end up back where we started. So addition and subtraction undo each other. They're inverse operations to each other. It works the same way with multiplication and division. If I have 3 times 5, that's 15. If I take that 15 and divide it again by 5, then that gives me 3. So 3 times 5 is 15. 15 divided by 5 is, again, 3. So these operations here, the multiplication and the division, undid each other. So it's basically like I didn't do anything at all. So inverse operations are opposite operations. And we're going to use those when it comes to solving equations. So just so we're clear, addition and subtraction are inverse operations to each other. So if I have addition and I want to undo it, I have to use subtraction. If I have subtraction and I want to undo that, then I have to use addition. If I have multiplication and I want to undo that, I have to use division. If I have division, I want to undo that, then I have to use multiplication. So this is important to know because this is what we're going to have to do to solve equations. You may already know how to solve these equations. If you do, you might want to pause it and work ahead of me to see if you come up with the same answer that I do. So here's your opportunity to pause it. I'm getting ready to start right now. So if you need to, pause it right now. Alright, so let's get started. So if we have the equation on the left, r plus 16 equals negative 7, we want inverse operations. So we remember, for addition, the inverse of addition is subtraction. So we're going to have to subtract. And just as before, whatever we were adding is what we're going to subtract. So since we add 16, we're going to have to subtract 16. We have a property of equality that says that if we want an equivalent equation that, and this is where I would ask students to do this, is to maybe draw a line here to separate the left side of your equation from the right side of your equation. So here's our equal sign. There's the left side of our equal sign and there's the right side of our equal sign. So once we've done that, then we can just go ahead and remember that we're going to have to do the same on the opposite side of our equal sign. Some students don't do this. They don't draw the line, or they don't, if you're not going to draw the line, then at least think about the fact that it has to be the opposite side of the equal sign. And they end up with an incorrect answer because they end up subtracting or adding to the same side of our equal sign. Remember, it's opposite sides of our equal sign, or equation. So left side of the equation, right side of the equation. Left side of the equal sign, right side of the equal sign. So once we do that, if we think about what would happen if we had, let's say instead of r, we put some number like 8. If we had 8 plus 16, take away 16, then that would leave us with just 8. In other words, 8 plus 16 is 24. 24 take away 16 is 8. So we end up with exactly the same thing. If we had x plus 16, take away 16, then it doesn't matter what number we put here for the 8. That's what this x means. Whatever number we put here, if we add 16 to it and subtract 16 to it, we end up with the same number. So x plus 16 take away 16. These undo each other, just like how these undid each other, and leave us with what we started with. So in this case, we'd have just x. And although it appears to be written differently up here, this is really r plus 16, then subtract 16. So these inverse operations are going to undo each other, and we're left with just r. On the left side, we have to remember how our operations work with integers. So if we have a negative and we're subtracting from it, then that's going into even more debt if we're subtracting a positive number. So negative 7 subtract a positive 16, I owe $7, and somebody comes and asks for 16, then now it's negative 23, or a debt of $23. So the solution to this equation is r equals negative 23. And of course we can check it, because if we put negative 23 back here where the r was, negative 23 plus 16, when we're adding and the signs are different, we end up with a negative answer. If you're confused about what's going on here, then you probably want to go back over your integers and practice it as much as you can. Or even you may want to come to a tutorial session where we can just deal with understanding what happens with the integers, because that's going to be crucial. If you're having trouble with this, please address it early, because it will not go away. It will just get worse. On the right hand side, we're going to do the same thing. We can separate the left and right side of the equal sign. So were we to do that, we would end up with something like this. And now we know that we're going to, since we have subtract 23 here, the inverse of that would be to add 23. Our property of equality says that we have to add to the other side of our equation exactly the same value to keep everything balanced or equal. So on the right side, we end up with 44. On the left side, remember, the inverse operations are going to undo each other. Addition undoes subtraction. Subtraction undoes addition. So all we're left with over there is just one u, or u. So u equals 44 is our answer. And if we did just a quick check, u minus 23 equals 21 was the original equation. If we put a 44 where the u was, 44 take away 23, and we're checking to see if it's equal to 21, we know that it does. And so we know everything is correct here. What we know about inverse operations is going to apply here also. So if you'd like to try it yourself, you can go ahead and do that first. Pause it at this moment if you need to, if you want to work ahead. Okay, so we need to know what this means. Sometimes students get confused about that, but when you see two values next to each other and there's no addition sign in between it, there's no subtraction, there's nothing in between it, it means multiplication. So this is really 5 times some number gives you or has the same value as negative 35. So to figure out what that is, we could do that in our head, but we want to develop skills that are going to help us with more complex problems. What we need to do is an inverse operation. So because we have a multiplication here, the inverse is division. So we're going to divide this side of our equation by 5 and the same over here. I didn't draw my line as I did before, but you could if you'd like to. Just remember, you're working with both sides of your equal sign. So 5 divided by 5 is 1. So over here, we end up with 1h. 1h is just h. So we could have just written h. In other words, the 5s, this 5 and this 5, multiply by 5 and then divide by 5, they're going to undo each other and leave just h. We're going to bring down our equal sign. We remember that a negative divided by a positive is a negative answer. So we end up with -7. Were we to do a quick check, let's see, 5h equals -35. If we substitute this h with the answer we just got, -7, it would look like 5 times -7. And we want to check if it's -35, which it is. So we know that what we did was correct. If we want to work with the one on the right, we'll do exactly the same thing. This time though, we'll note that it's a number divided by 121 gives us 3. So the inverse of division is multiplication. We're going to multiply by 121. Both sides of our equation. 121 and the 121 are going to undo each other. If you want to know a little bit more about why that takes place, we can look at that in class, but basically one of the key things is you're looking at inverse operations. Inverse operations will undo each other. So we're left with just x on the left side, and on the right we end up with 363. Were we to do a quick check, x over 121 equals 3, we want to see if that's true. We're going to substitute x with 363, and if we did that, 363 divided by 121 is 3, so we know that it's true. So here's another example. The operation here, what do you think it is? Two numbers next to each other, that's going to be multiplication. So the inverse of multiplication is division. So we're going to divide both sides of our equal sign by the same value that we were multiplying by. So the inverse of multiplying by 6 is to divide by 6. Our property of equality says that we're going to divide both sides of our equal sign or both sides of our equation by the same number. Inverse operations undo each other. I'm not using the word cancel because I want you guys to do I don't want you to overgeneralize and end up making particular mistakes. So let's just say undo each other. So we're going to end up with n here. 18 divided by 6 is 3, and so n is 3. If you want to check it yourself, if you put 3 back where the n is and see if it's true, we should end up with 18. 6 times 3 is 18, and so we know this is true. On the right side, we have multiplication. Two values next to each other. So the inverse is going to be division. So we're going to have to divide by whatever we are multiplying by. In this case, it's -5. We're going to do the same on the opposite side of our equal sign. These undo each other, and we're left with t equals, and a positive divided by a negative is going to be a negative. So this is a -7. And I'll leave that to you to check that yourself. For this example, we're dividing by 4, so the inverse is going to be to multiply by 4. And we have to do the same on the opposite side of our equal sign. These 4's undo each other, leaving us with just x. And this time I'm going to draw my line here. I don't have to, but let's go ahead and draw the line. 4 times negative 12 is going to be negative 48. So x is equal to negative 48, and you can check that yourself. For this next one, this one is interesting. You can look at it as multiplying by 2 and dividing by 3. So we want to switch that. We don't want to divide by 3. The inverse of that would be to multiply by 3. The inverse of this multiply by 2 would be to divide by 2. So the way that we would work that out is we'll think about this really as 2x over 3. We might think about it as really 2/3 times x. We want to get just x by itself. So what we're going to do is we're going to use the reciprocal or the multiplicative inverse to do that. So the multiplicative inverse is just changing the operations. Instead of dividing by 3, we're going to do the opposite here, which is multiply by 3. Instead of multiplying by 2, we're going to divide by 2. So we're going to basically multiply by the reciprocal. And I'm going to do this the really long way first, and then we'll go back and do this the much better way. So if we did this the really long way, just to justify it, we would end up with 3 times 2x. 3 times 2x gives us 6x. 2 times 3 gives us 6. So I'm just going to write that over to the side here. We would end up with 6x over 6, or divided by 6, equals, and something I forgot to do. Remember, we want to use our equality property to say that if we're multiplying by that factor on that side, we have to do the same on the other side as well. So let's just go ahead and draw a line to separate the two sides. If we continue the work, 8 times 3/2, we could put 8 over 1, and we would end up with 8 times 3 is 24, so 24 over 2 is what we get on the right side, and we still have this 6x over or divided by 6. Think about what happened in the previous examples. These 6's would undo each other. That leaves us with just x over here, and 24 divided by 2 gives us 12. So we end up with 12 as our answer. The slightly shorter way to think about this is to say, all right, these 2's may divide out. These 3's divide, in other words, 2 divided by 2 is 1. So these are going to divide out and leave the identity, which is not going to affect anything. These 3's are going to divide out. 3 divided by 3 is 1. 3 divided by 3 is 1. So all we're left with over here is just x. On the right hand side, we have 8 times 3/2. And I'm going to justify this in class, but we can think of multiplying by a fraction as really two operations. Multiplying by the numerator and dividing by the denominator. And the order in that case doesn't matter. Normally we go left to right, but in a fraction, there is no left to right. It's only top and bottom. So we just pick whichever one is convenient. I would rather say 8 divided by 2, which gives me 4, and 4 times 3, which is 12. So then my answer is going to be 12. If you need to, go back over this example, rewind it till you get it, but just remember that this fraction multiplying by a fraction is really two operations, multiplying by the numerator and dividing by the denominator. You might even make up a few examples or ask about it in tutorials if you need to. What you know about solving equations extends to whether it's a fraction or a decimal also. For example, on the left, we can solve that by doing the inverse operation. If you are not particularly enjoying how this is written, you can use the commutative property of addition to rewrite this. It would become s plus 7.3 equals 5.2. Notice that the expression on the left and the expression on the left here are equivalent. Remember, with the addition sign, we can move what we're adding around and end up with exactly the same value. So we can do that if we'd like to, but we don't have to. It's probably better to keep it as it is. Avoid all the confusion. We're adding a positive 7.3, so let's subtract 7.3 from both sides of our equation. These undo each other. 0 is what we have here, so 0 plus s is just going to be s. In other words, these undo each other and leave that positive s. So we're just going to write s on the left of our equal sign, and on the right, 5.2 take away 7.3. If I have $5.20 and I'm supposed to pay $7.30, I don't have enough, so I'm going to end up in debt. So it's a negative answer, and I need to subtract to find out exactly how much negative it's going to be. So in this case, it would be negative $2.10, or negative 2.1. So what I know on the right side would work as well. If I'm subtracting 3/4, the inverse would be to add 3/4. So I can add 3/4 to both sides of my equation, and on the right side, adding the same amount that I'm subtracting means that these values are going to eliminate each other. So I end up with just b on the left side. On the right, I have my equal sign, and then when I add negative 1/4 plus 3/4, remember the denominators will remain the same, and I'm just working with the numerators. Negative 1 plus 3 is a positive 2. So I end up with a positive 2/4. If you're struggling to understand this, likely it's a combination of maybe some work that we have to do with fractions. So please review fractions. Come to tutorials if you're having trouble with fractions, or integers. It might be an issue with integers as well. So figure out which one it is. We'll talk about it during tutorials, but review it. Keep reviewing these examples, and you might see a few things for yourself as well. But 2/4 is the answer, and if we wanted to go the extra step, we could simplify it to 1/2. So what we just looked at was just some setup information. We want to be able to find some useful information with what we just got. So here we have a triangle, and as we might remember, these lines written in the way that they are mean that this side is equivalent to this side. We're dealing with an isosceles triangle. So in other words, this side, which has a value of 30 yards, is equivalent to this side, which has a value of 9 plus 13 yards. I'm sorry, n plus 13 yards. So what this says is that 30 has the same value as n plus 13. And if we want to find out the value of n, it's as simple as using what we already know. We want to isolate the n. That means that we have to do an inverse operation here. We subtract 13 because that's what we were adding. our property of equality says that we're going to have to subtract 13 on the other side of our equal sign as well. So these 13s undo each other, and that leaves us with n. On the other side, we have 17. So we can read this as n has a value of 17. And we know it's true because if we put 17 here, 17 plus 13 is 30. So we know that that's true. This is something that's worth reviewing a few times if you need to. So remember that sometimes you're going to see this, adding a negative. Adding a negative gives you the same value as subtracting. As we did before, to prove it, you could say, okay, if I have $3 and I add in the fact that I'm supposed to pay $3 and you actually do, then that leaves you with nothing. This would be equivalent to 3 minus 3 equals 0. So if we ignore the numbers that are the same, we have 3 and 3 here, 3 and 3 here, and we focus in on just the signs. Adding a negative means the same thing as subtracting. Everything else remained the same, so that means that these two have to be the same as well. Adding a negative is subtracting. Similarly, we'll look at some examples in class, but subtracting a negative means addition. If you wanted to make a connection, think about what happens when you multiply. A positive, even though it's not positive, this is addition. A positive times a negative gives you a negative. So adding and subtracting, adding a negative has the same result as subtracting. So even though this is addition, we can pretend like it's a positive sign, and that's going to help us remember that. So positive times a negative gives us a positive. Positive times a negative gives us a negative. So in other words, if we're adding a negative, it's the same as subtracting. If we're subtracting a negative, it means addition. So just keep that in mind. Review this a few times if you need to. We'll look at some examples in class to justify it, or I'll have you prove it yourself. But just practice that. Do not put double signs. This is how your work needs to look. If you see this, change it to this. If you see this, change it to that. Please keep that in mind. So from what we just looked at, we definitely want to eliminate any kind of double signs. So we remember that when we have, for example, subtracting a negative, that we can combine the two to think of these two together as addition. So we can write an equivalent equation the following way. We can say that what we have up there is equivalent to negative x plus 2. Remember, subtracting a negative is equivalent to just adding. So subtracting a negative is equivalent to just writing addition. So we can bring our equal sign down and our 1, and now we can go ahead and start subtracting, or rather applying inverse operations. Because we have addition here, we have to apply the inverse operation, and the inverse of adding 2 is subtracting 2. We remember that we have to apply our property of equality. So because we subtracted 2 on our left side of our equal sign or equation, we have to also subtract 2 from the right side of our equation or equal sign. So we subtract 2 on this side as well. On the right side, if we add 2 and then we subtract 2, it was basically like nothing happened. So these are going to undo each other. And that leaves us with just negative x on the left side. On the right side, if you have $1 and you also owe $2, then you have to pay at least the $1 you have, and now you owe $1. In other words, 1 take away 2 is a negative 1. there are a few ways that we can interpret the situation that we have down here. One way is that we could think about this as really the opposite of some number has the same value as -1. And we know the opposite of 1 has the same value as -1. So that tells us that x has to be 1. But let's say that we didn't really understand that. How else can we think about this? We recall that from what we discussed with our axioms, that x is equivalent to 1x. In other words, 1 times a number has the same value as that number. So if I want to write that number, I can just put 1 times it and it means the same thing. For example, if I had 5, I could write it as 1 times 5. If I wanted to, it would mean exactly the same thing. Similarly, if I had 7, I could replace the 7 with 1 times 7 and it would mean exactly the same thing. So we have a lot that we can do here. We could even extend what we know to say, okay, if we have -x, then that must mean that it's the same as -1 times x. So let's say that we were to rewrite what we had here with that knowledge. So where we have -x, we could replace it with its equivalent value of -1x. So were we to do that, we have -1x instead of x, and everything else would remain the same. We still have our equal sign, we still have our -1, and so we remember that when we have two values next to each other, it means multiplication. So what we have here is really -1 times x. How do we undo multiplication? Well, we undo multiplication with division. So because we're multiplying by -1, we also now have to divide by -1. And because of our property of equality, that means the other side of our equal sign also has to be divided by -1. We remember that a negative divided by a negative is a positive. So we have this as +1. +1 times x is just going to leave us with x here. In other words, these two undo each other. Multiplying by -1 is undone by dividing by -1, leaving us with just x on the left side. Now we want to bring down our equal sign, and we again remember that a negative divided by a negative gives us a positive. So here we're going to end up with a +1. So however we look at it, we get x equals 1. We can check it if you can check it if you'd like to. Just substitute 1 where the x is and see if you end up with 1 for your final answer. If you don't, then that means that you probably have a small issue with integers that we can address in tutorials, or maybe you can just do some practice on your own to see if maybe you can improve your skills as it comes to integers. So what about the equation on the right side? How do we handle that? Well, again, notice that we have a double sign here. We have addition followed by a negative. So as before, addition with a negative is really like we put these two things together and think about subtraction. Almost like what we know about multiplication of integers. A positive times a negative is a negative, but we think about it more as subtraction. So these two together are going to be brought down as subtraction, and everything else will remain the same. So 2y, we still have 3, our equal sign, and our 7. So now we have 2y, take away 3 is equal to 7. So we have to undo our operations. We always undo addition and subtraction before anything else. So we would have to think in terms of what operation makes sense here? We could, first of all, look at our subtraction and think about, okay, if we have subtract 3, the inverse of that would be to add 3. So we're going to add 3 to the left side of our equation. Our property of equality says that if we add 3 on one side of our equation, we have to do the same on the opposite side of our equation, or equal sign. So we're going to add 3 right here as well with the 7. 3 plus 7 is 10. On the right side, if we subtract 3 and then immediately add 3, they undo each other. It gives us 0. And of course, 0 plus 2y is just going to be 2y. We bring down our equal sign. Again, we have a value or factor next to a number, means that we're multiplying these two. So there's no operation sign in between it, means that this is really 2 times y. What is the inverse of 2 times y? Well, the inverse of multiplying by 2 is dividing by 2. So our property of equality says that we have to do that to the other side of our equal sign as well. We divide by 2. These two are going to divide out. In other words, 2 divided by 2 is 1. And 1 times y is y. On the right side, 10 divided by 2 is 5. And so what we end up with is y equals 5. Again, to check to make sure our answer is correct, we can take that 5 and substitute it back in the original equation and see if we get 7. If we don't get 7, then that means either we made a mistake or we need to do a little bit more work with integers. Just a reminder as well, if we're having trouble deciding which operation we should do first, just to remind us about how to work with solving equations, we remember that normally we use order of operations, and this is what I'm writing here is not order of operations, but it's the way that many people remember order of operations. So first, normally we start here and we work out anything that's grouped. So it could be in parentheses, but it could be in other types of grouping symbols, which we're going to discuss what those are in class. But also, there's a prerequisite video that describes a few of these things as well, that if we haven't looked at it, we want to make sure we get a chance to look at that. So we work out anything, if we know the value, work out anything in a grouping symbol first, then work out anything with an exponent, then multiplication and division left to right. So if I have division first, going from left to right, let's say division is here and multiplication is here, then I would do division first and then multiplication. But if it's the other way around, where division is here and multiplication is here, then I would divide before I multiply. But anyway, we always work out multiplication and division ahead of addition and subtraction. Addition and subtraction are going to be done the same way, left to right. So if addition is on the left and subtraction is on the right, then we add before we subtract. But if it's the other way, where subtraction is first and then there's addition going from left to right, then we have to subtract and then add. So it all depends on what's first, going from left to right. So when we know the value, we normally work it going this way when we're evaluating. And we can get into a little bit more detail about this, but let's just be brief that when we're solving an equation, when we're finding a value, it's kind of like undoing everything. And when you undo something, you have to undo it in reverse order. So solving equations, you handle the operations this way. So in other words, you would have to eliminate addition and subtraction before multiplication and division, and so on. So if we use that with what we have here, notice that in this problem, which you may pause it to try and see if you can figure out systematically what x should be, but in this problem, notice we have multiplication and addition. So we have multiplication and addition. So we know we're supposed to eliminate addition first, then we eliminate the multiplication. And we use inverse operations to do that. So because we're eliminating addition first, what is the inverse of adding 2? Well, we remember that we have to subtract 2. So we're going to subtract 2 not just from one side of our equal sign, but we also have to subtract 2 from the other side of our equal sign or equation. Remember, we're trying to keep everything balanced because we're basically just writing equivalent equation. Each step is an equivalent equation to the step above it. In other words, the solution is going to be the same. We're not changing the problem. We're just changing how it looks. So these two are going to eliminate each other. So 6x plus 0 is just going to be 6x. 8 take away 2 is 6. So we see here 6 times some number has the same value as 6. We know this has to be 1, but let's write the next step anyway. The inverse of multiplying by 6 is dividing by 6. Our property of equality says that we have to do the same on the other side of our equation. 6 divided by 6 is 1, and 1 times x is just x. So these undo each other and leave us with just x on the left side of our equation. On the right side, 6 divided by 6 again gives us 1. So we end up with 1 as our solution. As a quick check, let's just put 1 in and check that. So 1 back here. 6 times 1 is 6. Add 2 to that, and that's 8, which is what we're supposed to have, so we know that it makes sense. So with the next problem, we're going to actually look at that one two ways. The first way is the traditional way. We're going to work it using what we know about order of operations or reverse order of operations. So we have division here and we have subtraction. So we have division and we have subtraction. From what we know, subtraction has to go first. So we're going to do the inverse of subtraction, and then we're going to do the inverse of division. So if we do the inverse of subtraction, inverse of subtracting 2 is adding 2. We have to do the same on the other side of our equation or equal sign. So we add 2 on the opposite side as well. These 2's undo each other. And so we're left with just m over 4 equals 10. We want to perform inverse operation, which would be, in this case, multiply. So we're going to multiply both sides by 4 since we're dividing by 4. These undo each other, and that leaves us with m equals 40. There's another way that we could have handled this as well. So let's say we went back a few steps and tried to see if there's anything that we could have done differently to get 40 as our answer. Which, by the way, if we put 40 back here, 40 divided by 4 is 10. And let's see, 10 take away 2 is 8. So just realized I made a mistake. So let's try that again. So we add 2 to both sides of our equation. This is why it's always good to check, because sometimes we make a mistake. These are going to eliminate. We're left with m over 4, and I think I know what my mistake was. I didn't add. 10 plus 2 is 12. So we end up with 12 on this side, and then we're supposed to multiply both sides of our equation by 4, and we end up with these eliminate, and we end up with m equals 48. We know that this is true because if we put 48 where the m is, 48 divided by 4 is 12, and 12 take away 2 is 10. So we know that that's true. But let's see if there's something else that we could have done. So let's just let me rewrite what I just erased. So multiply it by 4 here, and we got m was 48. So if we took that same equation, let's see if I could do it over here. 10 equals m over 4 minus 2. Let's say that we wanted to eliminate this divide by 4 first. What we could do is to think about, okay, we need to do basically multiply all of this side by 4 and all of this side by 4, and here's what it would look like. 4 times 10, and then this whole side by 4. So on the left side we end up with 40, and let's think about what would happen on the right. So we can apply the distributive property. This 4 has to be multiplied by this fraction. 4 times m over 4 is just going to give us m. And if we're not sure why, let's say we use a number instead of m. 5 over 4, as an example, times 4. If I put the 4 over 1, I end up with 20 over 4. I divide it, and then that just gives me 5. So in other words, 5 over 4 times 4 just gave me 5. From what we know, these 4's are going to eliminate each other because one represents multiplication and one represents division. So when we do the distributive property, 4 times m over 4 is just going to give us m. Now 4 times, this is subtract 2, but let's pretend like it's a negative 2 because it's going to work out the same. 4 times negative 2 is a negative 8, but we're going to write subtract 8. We apply our inverse operation. Note that we have subtraction here. The inverse of subtraction is addition, so we can add 8 to both sides of our equation, and we end up with 48 as the value of m. So sometimes, just like with driving, there's more than one way to get to a place. There's more than one way to solve an equation. We just have to make sure that what we're doing is mathematically correct. But a good starting place is to use reverse order of operations to decide which one to get rid of first in order to isolate our variable. Here's an application of what we just learned about solving equations. This doesn't look like equations, but it actually is. These are matrices. So in order for one matrix, so this is a matrix here, in order for one matrix to be equal or equivalent to another matrix, then each row and column have to be equivalent. So 2a plus 1 has to have the same value as 11. X minus 5 has to have the same value as negative 6. 5 minus 2y has to have the same value as negative 7. Negative 3k has to have the same value as 27. So let's go ahead and solve these. So if we started with, we're going to start with this first, these two first, then we're going to do the ones in green, then the ones in blue, and then finally these two here. So starting with that, we have negative 3k equals 27, and we know the inverse of multiplying by negative 3 is to divide by negative 3. So we do that to both sides of our equation. Negative 3 divided by negative 3 is a positive 1, and 1 times k is just k. And then on the right, a positive 27 divided by negative 3 is a negative 9. So k has to be equal to a negative 9. So let's look at the rest of these. So we did this one here. Now let's do the one in green. So 5 minus 2y has to have the same value as negative 7, because they're in the same row and column. So we want to eliminate the constant first. So this 5 has to go. So it's a positive 5, meaning that we're going to subtract 5 from both sides of our equation. So we said that we eliminate addition and subtraction first. There are so many ways that we can think about this. We could even think about this in terms of the commutative property. This subtraction is like adding a negative. So if we wanted to, just for the sake of showing why this makes sense, this is really 5 plus a negative 2y equals negative 7. From what we know, we're just working backwards from what we said about double signs. Remember, adding a negative is equivalent to what we have here, which is subtraction. So because they're equivalent, that's what really allows us to do that. So now we could rewrite this as negative 2y plus 5 equals negative 7. So just we'll do these two problems side by side or in close proximity, so you'll see that it's the same result. But the equation that we have down here is equivalent to the equation that we started out with there. So if we were to continue, let's say with the one on the top, 5 take away 5 is 0. So up here we have 0 minus 2y. And of course, if we subtract from 0, it leaves us with a negative. So we would end up with a negative 2y. So the result of that first subtraction is negative 2y. We bring down our equal sign. A negative 7 take away 5. If I owe $7 and somebody tries to get $5 from me, I'll just have to owe them 12. So it'll be a negative 12. We can divide both sides of our equation by negative 2 to undo the multiplication operation, and these divide out as 1. 1 times y is y, so we end up with y equals, and then on the other side, a negative 2 divided by negative 2 is a positive 6. So we get y is equal to a positive 6. We could work out the one on the bottom now to see if we end up with the same result. So if we were to subtract 5 from both sides to undo the addition operation here, we would end up with negative 2y equals negative 12. This is exactly what we had for the work above it, so everything else would remain the same. We end up with y equals a positive 6. So as we said before, there's often more than one way to arrive at the solution to a problem. But in any case, we end up with that y has to equal a positive 6. Alright, so let's just erase this here. And now we're going to work out the next one, which is what we have here. X minus 5 has the same value as negative 6. So x minus 5 has the same value as negative 6. We undo subtracting 5 by adding 5 to both sides of our equation, applying our property of equality. These 5's eliminate each other, and that leaves us with just x. We bring down our equal sign. Negative 6 plus 5, if I owe $6 and pay 5, that's not enough, I still owe 1. So it's a negative 1. So we know that x is equal to a negative 1. So we can continue on to the last part, of our problem, and we have here 2a plus 1 has the same value as 11. So 2a plus 1 has the same value as 11. We apply inverse operations. The inverse of adding 1 is subtracting 1. So our property of equality says that we're going to subtract 1 on the other side of our equation also. 1 take away 1 is 0, and 0 plus 2a is 2a. So we bring down our equal sign, and on the other side we're going to end up with 10. The inverse of multiplying by 2 is dividing by 2, so we're doing that to both sides of our equation. These 2's, 2 divided by 2 is 1, 1 times a is a, they eliminate each other, and that leaves us with just a on the left. And 10 divided by 2 is 5, so we end up with a equals 5. So if we wanted to write the solution, actually, if we wanted to write the solution, then we would have to evaluate the expressions. So we already know that in the top right here, were we to substitute 6, that negative 9, we would end up with 5. 2 times 5 is 10. 10 plus 1 is 11, as was already written, so we end up with 11. Similarly, for the others, we would have negative 6, negative 7, and 27 as the resulting values. But the point of it really was to find the value of a. And so a, x, y, and k, and which we did that, so that was just one application for solving equations. Here's a word problem that its application would require us to solve an equation. Pause this and see if you can come up with the equation yourself and also its solution. Okay, so in order to solve this equation, we have to figure out what's going on here. What's the overall idea? So notice it says that you have $14 to spend. You can't spend more than that. So everything that you do has to have a total of $14. So basically, when everything rings up, and we're going to put that here, when everything rings up, it has to have a value of $14. So the other part of it is this statement that it costs 75 cents plus $3 shipping. So each bulb costs 75 cents. So in other words, if we paid for one bulb, it would be 1 times 75 cents to figure out the cost. If it's 2 bulbs, it would be 2 times 75 cents just for the cost of the bulb. But we also have to add in the $3 shipping. So in other words, we don't know the number of bulbs, but we know that we'd have to multiply it by 75 cents. So, and it's asking how many bulbs, so that would be our x, or our unknown. Whatever that is, that has to be multiplied by 75 cents. So 75 cents times what we don't know, and it says plus $3, so plus $3, and all of that has to have a value of $14. So our equation makes sense so far. Now we just need to solve it. We apply inverse operations as one of the ways that we can do this, and I'll show you another way afterwards that this could same problem could be done. We would need to subtract 3 from both sides of our equation, and then this is 75/100 x on the left side. After these eliminate, we bring down our equal sign and we have 11. So just a few ways that it could diverge from this point. I'm just going to draw an arrow and show how this could look from this point. Let's say you didn't want to deal with the decimal. Sometimes students are scared of fractions, but this is a perfect case for why a fraction would be a useful thing. If we recognize that 75 cents is really 3/4 or 3/4, then this equation is just 3/4 x is equal to 11. We remember that our objective is to get x by itself. In other words, we just want 1x. This would be the same as just saying that we just want 1 to be multiplied by x. We remember that multiplying by the reciprocal or multiplicative inverse is going to accomplish that. So if we multiply this side by 4/3, remember that 4/3 times 3/4 is really just 12/12 or 1. So if we multiply by 4/3, then we accomplish our goal of getting 1x or just x. But our property of equality says that if we do that to one side, we have to do that to the other side as well of our equation. So these are going to just give us 1x. So 1x is equal to 44, whatever 44 divided by 3 is. As long as we can get here, then that is sufficient. So another way that we could have handled this was when we got to the part where it was that decimal value, is that we could actually eliminate a decimal value to make the equation more solvable. And if you're finding that you're having some difficulty understanding this explanation, remember, the good thing about this being a video is you can always go back and look at it a few times. If it's still troubling you, then you can ask about this specifically when we have tutorial sessions. But one thing that you can do is remember what happens when you multiply by 10. If you can try it yourself, but if you put this into the calculator, 123.45, and you multiplied that by 10, then you would end up with 1234.5. Notice that all the digits are the same, but the decimal point just moved over one space to the right when we multiplied by 10. If you took that same number and multiplied it by 100 instead, the difference, well, what do you think the difference would be? So try it out on a calculator so you can see it for yourself. But if we multiplied it by 100, we would end up with 1234.5 point whatever, 0.0, I guess. So multiplying by 100 moves the decimal point twice. This is useful to know because that's going to help us eliminate decimal points in certain equations. For example, in the equation that we have down here, we could multiply this side of our equation by 100, the whole side, that's why I put the whole of the left side in parentheses, and the whole of the right side by the same value. What that's going to accomplish is when we multiply 100 times this decimal value, it's going to move the decimal point 2 times and make it a whole number, 75. So we would have 75x, and you can try it yourself, confirm it on a calculator, but you are going to get 75. 75x equals 1100, so 1100. Then we apply inverse operations and divide both sides by 75, and we end up with x equals 1100 divided by 75. And some people are like, wow, that really doesn't look like the answer that we had before. But remember, this is something that we can simplify. if we divided this fraction by 25 over 25, and why I'm only doing this to one side is because I'm not really changing the value of that side. We're just simplifying. We're writing an equivalent fraction. So were we to continue, we would end up with 44 over 3, which is exactly what we had before. What if we had variables on both sides? Well, what we would want to do in a case like that, let's say what we have on the right, is we want to eliminate the variables from one side so it would look like something we already know. So this is a useful problem-solving technique, no matter what level of math we're at. Remember that we can always make a problem into something equivalent that's a little bit easier to handle. So if we apply our property of equality, we know that if we were to subtract, let's say 2x, and why we're doing 2x is because it's a smaller value. If I use 3x, I would end up with a negative and provides an unnecessary, I'll still get the same answer, but it provides an unnecessary step. So we subtract 2x from the other side as well. Notice that I'm drawing my line here because I want to remember that there is the right side of my equation or equal sign and there's the left side. So if I've written subtract 2x here, or subtract 2x here, then I know that I did something wrong because my property of equality says that one side, the right side, and the left side get the same treatment. So if I subtract 2x from the right side, I also have to do it to the left. Notice also that when I subtracted, I made sure that the like terms were together. So both of these, think about it like a family. Both of these would be in the same family. They share the same last name. Their last name is exact. So 2x, take away 2x would be 0. And 0, take away 1 would leave me with, on this side, just a negative 1. And that would be true because essentially the subtraction, even though we know it's subtraction, we can treat it like a negative, and what we've just done shows us that it works out exactly the same way. So these two, we can say that they eliminate each other, and that subtract 1 can be written as a negative 1. So we bring down our equal sign. 3x take away 2x is just x. We bring down our plus 2 and apply an inverse operation. The inverse of addition is subtraction. We subtract 2 from both sides because that's what we were adding. The 2's are going to eliminate each other. In other words, add 2 and subtract 2 gives you 0. 0 plus x is just x. Bring your equal sign down. A negative 1 take away 2 is a negative 3. So x equals a negative 3. And we know this is true because were we to go back and put this negative 3 here and here, we're going to end up with the same value. So let's just demonstrate that that's actually going to take place. So if we had 3x plus 2 equals 2x minus 1, and we're checking if that's going to work out, we're going to put a negative 3 where the x is. So 3 times negative 3 plus 2 should have the same value as 2 times negative 3 take away 1. 3 times negative 3 is a negative 9. So negative 9 plus 2 equals, and 2 times a negative 3 is a negative 6. And then we still have our take away 1. When we're adding a negative and a positive, we have to subtract their absolute values. So 9 take away 2 is 7. And the larger absolute value is the 9. So we're going to put a negative sign because that has the larger absolute value. We bring our equal sign down. If I owe $6 and someone asks me for $1, I owe 7. So notice that I end up with the same value. So negative 3 will make that equation true. So I know that negative 3 is a solution. But that's how you would go about checking it. Make sure if you have time, particularly on tests, to go back and substitute to check if your answer makes sense or not. So now let's do the other side. Remember, you can pause at any time, try it out yourself before I do it, and see if you come up with the same answer that I do for the same reasons. Of course, remember that it's not just about getting the answer. We also want to have a systematic approach to get that answer. So here, we want to eliminate the variables. We're going to choose the variable that's the smallest. So negative 3 is smaller, or really eliminate the variable that has the smallest coefficient. Negative 3 is smaller than 8. So this has a coefficient of negative 3. That's that numerical factor. The number in front of the variable is called the coefficient. So negative 3 is smaller than 8. So we want to eliminate this one to make our equation more manageable. The opposite of negative 3 is a positive 3. So we're going to have to add 3y to this side. And remember, draw your line to make sure that you're really working with two sides here of your equation. So we add 3y to one side of our equation, and our property of equality says that we have to do the same to the other side. 8y plus 3y is 11y. We bring down our subtract 9, and on the right side, what we have here, negative 3y plus 3y, is like saying, what if we had negative 3 plus 3? Well, this would give us 0. So in other words, these two values here, negative 3y plus 3y gives us 0. 0 plus 2 is 2. So we end up with this equation, 11y minus 9 equals 2. We apply inverse operations. We add 9 to both sides of our equation. These eliminate, and that leaves us with 11y equals 11. We apply our inverse operation. Inverse of multiplication is division, so we divide both sides of our equation by 11 and end up with y equals 1. We can check it by substituting as well. And just so you have enough examples of how to check your work, we're just going to work this one out too. So 8y minus 9 equals negative 3y plus 2. If we substitute 1 where the y is in all the places that the y is, so 8 times 1 minus 9 should give us the same value as negative 3 times 1 plus 2. 8 times 1 is 8. Take away 9. And then we have negative 3 times 1 is negative 3. We still have to add 2. 8 take away 9 is a negative 1. Negative 3 plus 2 is also a negative 1. And so we end up with a true statement. We know that our answer is correct. Although there are multiple ways to work out solving these equations, some ways are more efficient than others. And really, to determine that is really just a matter of practice. So we want to try and get as much practice as we can. So what I'm going to do with the first equation is you can pause it to try it yourself if you'd like to. But we're going to look at a couple of things that we can do. Let's try it the long way first, a really long way, and then we'll look at a much simpler way that we can approach this problem. So the really long way, some see this negative 7 here with this grouped expression, and they correctly interpret that you can do negative 7 times x and negative 7 times, even though we know to subtract 3, we could pretend like it's negative. So negative 7 times a negative 3, which would give us a positive or plus 21. So how they would write it is they would say, and that's the distributive property that we're applying, how they would write it is they would say negative 7x plus 21, and then we still have the plus 15 from above, is equal to negative 7. So remember, the distributive property, you're only applying to what's inside of the parentheses. So we could here try to combine our like terms, so we end up with 21 plus 15 is 36. So we end up with negative 7x plus 36 equals negative 7. We apply what we know already. We subtract 36 from both sides because that's the inverse operation, both sides of our equation. And we would end up with these eliminating each other for the reasons mentioned before. Negative 7x equals negative 7, take away 36. If we owe $7 and we have to pay somebody 36, we owe them even more, so it would be a negative 43. We divide both sides of our equation by negative 7 to do the inverse operation. These become a positive 1, leaving us with just x, and we would end up with a positive 43 over 7, which we could do some more work with, but if we leave it as it is, then that's fine. That's fine too. But in terms of how else we could have done this, given the problem that we started with, I actually would have preferred to do something else. So let's take a look at that. Instead of applying the distributive property first, what we could have done was to subtract this 15. So we want to get the grouping symbol essentially isolated. It's like one big variable, one big unknown. These 15s would eliminate, and we're left with just negative 7 times some unknown is equal to, in this case, negative 22. We could divide both sides of our equation by a negative 7 to get the x minus 3 by itself. So these eliminate. You end up with x minus 3 equals a positive 22 over 7. And it's starting to look similar to what we had before, but not quite the same. So this is going to be, we're going to have to add 3 to both sides of our equation. And keep in mind that if we wrote 3 with a denominator of 7, so think about it, 3 is 3 over 1. How can we get from that fraction to the other? Well, we multiply by 7 over 7, and it's really 21 over 7. So when we're adding 3, we're really adding 21 over 7. So we end up with these eliminating each other. When we add the 3 on this side, we're adding 21 over 7 with the 22 over 7 that was already there, and that's going to give us 43 over 7, which is what we got before. Notice that we got the same answer, but we got it with a whole lot less work. So this is just really useful to know. Work with the method that is going to be mathematically correct, but is going to be the most efficient. For the second equation, we want to, if we can, combine like terms. So combine like terms and apply the distributive property is a good way to start when you're dealing with these kind of multi-step equations. We notice that 2c and 1c are in the same family. In other words, they're like terms. So 1c plus 2c's gives us 3c's. So that would be 3c. These two together would combine to be 3c. We bring down our plus 12, our equal sign, and our 78. Now we have a much simpler equation to solve. We're going to apply inverse operations subtract 12 from both sides of our equation, these 12s eliminate. That leaves us with 3c on one side, and we're going to have that equal 66. Our inverse of multiplication is to divide by 3, which again is equivalent to multiplying by 1/3, and we're going to end up with c equals 22. And we can check it by substituting our value into the original equation. So 2 times 22 is 44. 44 plus 22 is 66. And 66 plus 12 is 78. So we still end up with the same answer. We know that our equation is correct. Our solution to the equation is correct. Before we solve these equations, just a quick reminder about dealing with fractions, especially as it comes to multiplication. If we had, let's say, something like 3/4 times 20, we could do it the really long way and put 20 over 1, and then we have 3 times 20 is 60. So in other words, we're multiplying by this number, and then 4 times 1 is 4, and we're going to end up dividing by 4. So we're dividing by this number, and we end up with 60 divided by 4 is 15. So in other words, 3/4 times 20 is 15. We would have gotten the same answer if we had just thought about what each of these numbers meant. So the 3 meant multiplication and the 4 meant division. We could have just looked at it and said 20 divided by 4 is 5, and 5 times 3 is 15. What about if we had, let's say, something like 3/8 times 8? What do you expect the answer to that for that to be? Well, using the same reasoning, this 8 represents division and this 3 represents multiplication. So 8 divided by 8 is 1, and 1 times 3 is 3. So we anticipate this being 3, and if you did it the particularly long way, then you would end up with exactly the same answer. Of course, I'm leaving out the fact that you can simplify during a multiplication problem. We'll discuss that a bit more in class, but just keep in mind that there are simple ways that we can think about multiplication with fractions. What if we had, let's say, 1/4 times 8? What do you anticipate the answer for that to be? Well, 8 divided by 4 is 2, and 2 times 1 is 2, so we end up with 2 as our answer. So what that means is that's going to help us figure out a couple of things here. Firstly, notice that what we have on this side here is we have a whole bunch of fractions, and that's going to make some people scared. But what if we took the least common multiple of all of these fractions, of the denominators at least, the least common denominator? So the least common denominator for all of these fractions is 8. That would be the common denominator we could use for all of these. So what if we multiplied by that number? So 8 times this whole side here and this whole side times the same number to keep our property of equality. So we remembered what happened with 8 times 3/8. We just did it and ended up with 3. When we did 8 times 1/4, we got 2. So 2x. We bring down our equal sign. Now on the other side, 8 times 1/2 is really just 8 divided by 2, and that's going to give us 4, so we have 4x on that side. Then we have 8 times 3/4 is really just 8 divided by 4, which is 2, times 3 is going to be 6, so we have -6. So what looked like a very difficult problem is actually something that's very easily done. So we just have to eliminate a variable and then do what we did in the previous examples. So when we look at it, We know this is subtraction, but we pretend like it's a negative. A negative 2x is smaller than a positive 4x. So we want to eliminate that first. The inverse of subtraction is addition, so we add 2x to both sides of our equal sign. These are going to eliminate, and that leaves us with just 3. Bring down our equal sign. 4x plus 2x is 6x. Bring down our subtract 6. So there are a lot of things that we could do at this point, but why not finish this problem the more traditional way? Let's add 6 to both sides of our equation. We end up with 9 on this side, and these 6's are going to eliminate. In other words, if we subtract 6 and add 6, we end up with 0. 0 plus 6x is 6x, so we end up with 6x here. Let's draw this line down a bit further. Put 60, I meant to put 6x. Divide both sides by 6, and we end up with x being equivalent to 9 over 6, which we can simplify if we'd like to. Divide by 3 over 3, and we end up with x equals 3 over 2, or 3/2. So 3/2 is our answer. Again, remember, this is a video, so you're welcome to go back and review it if at some point you had some trouble with how we arrived at our answer. Although there are multiple things that we could do for the second equation, why don't we try this one with the distributive property? So 3 times x would be 3x. 3 times plus 4, or positive 4, would be 12, or positive 12. So I'm going to write plus 12. We bring down our equal sign. 2 times x, we write 2x. 2 times, and notice again here, this is subtract 1. 2 times this is going to work out the same as if we were to do 2 times a negative 1, which is going to be negative 2. So we're going to write subtract 2. We need to isolate our variable, or really just get the variable to one side by itself. So we're going to eliminate either the 3x or the 2x. We want to do the smaller of the two, and obviously 2x is smaller than 3x. So we're going to subtract 2x from both sides of our equation. Notice that we're putting everything with the like terms. 2x minus 2x is 0. 0 minus 2 is negative 2. On the left side, 3x take away 2x is 1x. We bring down our plus and our 12, and now we're going to solve this equation. The inverse of adding 12 is to subtract 12. So we subtract 12 from both sides of our equation, and we end up with x equals negative 14. And we could substitute to verify our answer. I know we didn't check the last few, but why don't we check this one? Let's say we put a negative 14 everywhere we see an x here. So negative 14 plus 4, so negative 14 plus 4 is really a negative 10. So we would have negative 10 as the value inside of the parentheses. We put negative 14 here. Negative 14 take away 1 is negative 15. So when we look at it, the right side says 2 times negative 15, which we know is negative 30. The left side says 3 times negative 10, which is also negative 30. So we know that what we did made sense. Here's another application problem. Remember that you may pause it at any time to try it yourself. So in this problem, some students get confused with the fact that it says $60 per month and think that they have to multiply $60 times the number of months. But remember, the information we're considering is for her bill this month. So it doesn't matter that it's per month. It's just she's going to be charged $60 plus some additional amount. So she's going to be charged $60. We know her total bill was $92. So after we add the $60 plus whatever is going to happen that month, it all has to add up to $92. So the other part of her bill, besides the $60, is this 10 cents per minute, but it says it has to be over 500 minutes. So it's going to be 10 cents times some unknown amount, and the unknown amount is the amount over 500 minutes. I would write this problem a little bit differently if they were asking how many minutes she spent calling, but it said how many minutes she was billed over the 500 minutes. So that's really the same unknown that we're multiplying by 10 cents. So we want to know how many minutes were billed over the 500, and that's what it says up here, that it's 10 cents per that amount. So it's going to be 10 cents times the number of minutes that she goes over by. Let's just write this equation a little bit better though, so that it's easier to see exactly what we need to do. So we want to eliminate the constant term first. We want to get rid of that 60. So we subtract 60 from both sides of our equation. And on the left, these 60 subtracted would give us 0. 0 plus 1/10 of x is 1/10 of x. And I know I put a 0 here, but I actually prefer not to have it because it doesn't add anything to the value of the number. So we're just going to write it as 0.1x. It's the same information, equals 32. From this point, we could do one of two things. So sometimes fractions are just a lot better to work with. I think I'd like to do this with a fraction first and then come back and do it the other way. So if we were to rename the decimal, 0.1 is really 1/10. So 1/10 x is what we have on the left and on the right, and that's equal to 32. As we said before, we can multiply by the reciprocal, which in this case would be 10 over 1 or 10. So we multiply this side by 10 also. These undo each other as we had in the previous example, and we end up with x equals 320. So basically she went 320 minutes over. If we did it with what we had previously, we would have to divide this side by 1/10, divide this side by 1/10. These eliminate, and now we have to do the extra unnecessary step of doing our decimal division. So we have to move the decimal point, which corresponds to a mathematical operation. Same thing here, move the decimal point once, put a 0 here. This ends up being 1 as our divisor and 320 as our dividend. And we know that 320 is what we would end up with. So the same process, but an unnecessary amount of work. And so we end up with x equals 320. So sometimes fractions can actually make the problem easier. We end up with 320 in either case, but one is easier to work out than the other. Here's another practical application problem. So a good strategy here, whenever something is described to you, but no picture is given, is to actually draw it out. So it mentions a rectangular garden. So let's draw a rectangle. Better yet, let's put this rectangle in a different place. So our rectangular garden, why don't we put the rectangle here? So we have a rectangular garden, and we know that we take all this additional information. It's built up next to a fence. This side, they say, is 12, the width is 12 feet. And because it's a rectangle, the opposite side also has to be 12 feet. And they're asking how long will it be. So this is the length, we don't know. And the opposite side is the same length. But they tell us that you have 44 feet. In other words, the perimeter, when we add up 12, 12, x and x, the most it can be is 44. It should be 44. The idea, I guess, here is that we're using all of the materials. So, in other words, x plus x, or x times 2, plus 12 plus 12 should equal 44. So we end up with these two together combining to be 2x, and these two together combining to be 24, and all of that has to equal to 44. So this is the equation that we need to solve. To solve it, we need to apply inverse order of operations. We're going to subtract 24 from both sides of our equation. Because of our property of equality. Then we're going to have those be 0. Plus 24, subtract 24 is 0. 0 plus 2x is 2x. In other words, they undo each other. We bring down our equal sign. And 44 take away 24 is 20. We divide both sides of our equation by 2 in order to isolate the x. And we end up with x equals 10. So in other words, if we were to redraw our rectangle, this side is 12, this side is 12, this side is 10, and that side is 10. And we know that 10 plus 10 is 20, and 12 plus 12 is 24. So 20 plus 24 is 44. So we know that everything works out according to the information in the problem. Let's see what happens with what we have here. So let's say we were to work out the equation on the left. So we want to eliminate the constant term, or actually let's try and get the variable by itself. We have a variable on the right, variable on the left of the equal sign. They're the same, so it doesn't matter which one we pick. Let's just subtract 12x from both sides of the equation. And now we end up with these eliminate and these eliminate. Oh, that's a problem because there's no variable now. So now we just have negative 3 equals negative 3, which is true. It's always going to be true. So if we think about what numbers would make that equation true, any number would make the equation true. So this is what's called an identity. So when we work everything out and end up with the same value on both sides, it's called an identity. And we'll look at exactly why. So what we're saying is that any number, if we were to put it here, where where the x is, would make this true. So there are infinitely many solutions. There are as many solutions as you can think of to this equation. So any number would fit here. If I put 5 here, so it would be 12 times 5 on this side and 12 times 5 on that side. Subtract 3 here, add a negative 3 here. So 12 times 5 is 60. So this is 60 here, plus a negative 3. Bring down an equal sign. Again, 12 times 5 is 60. So we bring our 60 down and subtract 3. And 60 take away 3 is 57. So we have 57 on that side. And on this side, negative 3 plus 60. When we're adding and the signs are different, we have to subtract their absolute values. So 60 take away 3 is still 57. And it's a positive 57 because the 60 has a larger absolute value. So yeah, we end up with the same answer on both sides. You can try it yourself if you'd like to, but you'd end up with exactly the same answer if you were to try a different number. So that is an example of an identity. Why it's true is because if you look very carefully, you'll notice that it's the same expression on both sides. If we were to use the commutative property to rewrite what we have on the left here, to rewrite this, remember we can interchange, because it's addition, we can switch the 12x with the negative 3. Remember when we have 5 plus 3, how it's the same as 3 plus 5, it has the same value, that we can switch them around? Well, the same is applicable here. So this may be rewritten as 12 plus 12x plus negative 3 equals 12x minus 3. Remember, we have a double sign here. The double sign means the same thing in this case as subtraction. So this is really 12x take away 3 on that side, and 12x take away 3 on the other side. So we're saying something is equal to itself. So that will always be true no matter what number you put in there. So this is a case of an identity, or every value would keep the identity of the equation as accurate. If we look on the right, this is also another case of an identity, because if we apply the distributive property, 3 times x, we're going to write 3x. 3 times 1 is 5. So this may be rewritten as 3x plus 3 take away 5 is equal to 3x minus 2. So when we combine our like terms, 3 take away 5 is a negative 2, and we're going to rewrite that as subtract 2. So this would be 3x subtract 2 on that side, and we already have 3x subtract 2 on that side. We don't have to do all the work we did in the previous one, because we know it's going to be exactly the same thing. If we were to go the step of trying to isolate x, we have the same coefficient, so we're going to end up with the same result. Negative 2 here and negative 2 here. This is another case of an identity. So here again, any value of x would make this equation true. There are infinitely many answers. There are also situations where we wouldn't have a solution. In this case, as an example, let's say that we tried to isolate a variable to one side by subtracting 2x from both sides of our equation. So notice what's going to happen here. We end up with 0 here. So these undo each other. We end up with 0 here. These undo each other. So on the left side of our equal sign, we have 5. On the right side of our equal sign, we have negative 3. Will it ever be true that 5 equals negative 3? No, because they're completely different numbers. So this is not a true statement. So no number that you substitute for x will ever make it true. So there is no solution in this case. So there is no solution in the first case. Were we to look at the second example, 6m minus 5 equals 7m plus 7 take away m, we can first combine our like terms. Notice that 7m and subtract m are the same. So if we just ignore this for a second and put these two together, just over to the side, 7m take away m has the same value. So 7m's, and if I remove one of them, it gives me 6m. So on this side, when you combine the 7m with the subtract m, it gives you 6m, and you still have that plus 7 up at the top. You bring down the 6m minus 5 on the right, and notice that if we subtract 6m from both sides of our equation here to isolate the variable to one side, that on this side, that's fine, 0. This side, it's 0. We end up with negative 5 equals a positive 7. That will never be true. So again here, it's another case of no solution. So don't just assume that every equation has only one solution. Sometimes there are infinitely many solutions. In the previous case, all values of x would make sense there. In other words, all real numbers would be a solution. in the case of an identity, in the case of no solution, no real numbers, there is no value of x that will make that equation true, as in the two examples that we are looking at right now. Based on what we've just discussed, try these yourself first. I'm going to work out each one, but make sure that you choose a method in the following problems. Choose a method that makes sense to work this out. So remember, pause it, try it yourself first, but the solution is going to come up. All right, in this problem, remember that the line in between the numerator and denominator is not just division, but it's a grouping symbol. It makes two groups. One group is the numerator and the other group is the denominator. So here, even though it's not written, there's one big parenthesis around the numerator because it's all grouped. So we're dividing all of that by 2. The inverse of that would be to multiply by 2. So we can multiply both sides of our equation by 2. These 2's are going to eliminate or undo each other, and that leaves us with just d minus 4 on the left side, and on the right side of our equation we would have 6. So simply we would just add 4 to both sides to undo that, and we would end up with d equals 10. We know that's true because were we to go back to the original equation and substitute 10, let's see what would happen. So 10 take away 4 is 6, and 6 divided by 2 is 3, so we know that 10 makes sense as a solution there. Let's try the next one. We could, as we did on the left, multiply both sides of our equation to undo the division on the left side by 3. These 3's eliminate each other or undo each other, and that leaves d plus 1 on the left side and negative 18 on the right. The inverse of adding 1 is subtracting 1, so we subtract 1 from both sides of our equation. These undo each other, and that leaves us with d equals a negative 19. And I'll leave that to you to check that one. You're welcome to try this one as well. So in this case, it's $4 per movie rental. So if we were to figure out the unknown, we don't know how many movies you're renting, and it's $4 per movie rental, so that's 4x. And that's the cost for non-members. For members, we would have to factor in the $21 membership cost plus the $2.50 that you have to pay for each movie. So that would be $2.50 or 2.5 times the number of movies. We know that this has to be equal because they're asking for what number of videos would the cost be the same. So if we put these as equal to each other, now we have an equation that we can solve. So if we were to solve this, then we want to eliminate the variable from one side. Remember that we're trying to eliminate the smaller of the two. So this 2.5x compared with the 4x has to go. So 2.5x is smaller or has a smaller coefficient. So we subtract 2.5x from both sides of our equation. On the right side, this gives us 0. 0 plus 21 is 21. And now 4 take away 2.5 is 1.5. So we have 1.5x. We could divide both sides by 1.5 and get the same answer. But in this case, I actually would kind of like to work with fractions. So I make the claim that 1.5 or 1 1/2 is really the same as 3 divided by 2 or 3 halves. So 3 divided by 2 is 1.5. So this equation, I would prefer to write it as 3 halves x equals 21. So that means that I can multiply by the reciprocal, in this case 2/3, to get the x by itself. I'd have to do the same to the other side of my equation as well. Over here, these undo each other and leave x. Think about what happens when you multiply by 2/3. This 2 is one operation and this 3 is another. So we have to multiply by 2 and divide by 3, or divide by 3 and multiply by 2. I prefer to do the division first, especially considering that 3 and 21 are compatible. 21 divided by 3 is 7, and 7 times 2 is 14, so we end up with 14. So at 14 movies, the cost would be the same. If you chose to use a decimal, here's what that work would look like. If we divided both sides by 1.5, we know these would eliminate, and we would just need to figure out what 21 divided by 1.5 would end up being. So we would have to move the decimal point once here. 21 has a decimal point here, move it over once, add a 0 in the empty space, so we're really just dividing 210 by 15. 15 does not divide into 2, or you can't get $15 out of $2, $15 out of $2. But you can get $15 out of $21, and you can do that exactly once. So we would put a 1 here above the 1 for the 21. 1 times 15 is 15. You subtract that, you get 6. You bring down your 0, and you can get 15 out of 60 exactly 4 times, and that's 60. Subtract that, that's 0. So we end up with exactly the same answer, that x equals 14. But again, it's a matter of what's efficient. Doing it with a fraction, as you can see, is actually easier than working with it as a decimal. Here's another practical application. So with length and width, in this case they're saying that the length of a rectangle is, that's an indication that we're dealing with an equal sign. So the length is 4 inches greater, so 4 plus greater than the width. So the length is going to have a larger value than the width. So if the width is 2, 2 plus 4 is 6, then the length would be 6. So the length is 4 inches greater. Alright, so when we see the length, we can replace it with 4 plus the width. It means exactly the same thing. So they also mention about the perimeter. They say the perimeter is 24 inches. We know that for the perimeter, you'd have to do 2 times the length. Perimeter is 2 times the length plus 2 times the width when we're dealing with a rectangle. The perimeter, they say the perimeter is 24. So the perimeter is 24 inches. So where we see the P, we can replace it with 24. So we're going to put 24 where the P is. We said that we could replace the L with 4 plus W. So we're going to do that. 2 times the quantity of 4 plus W, and this 2W is going to be exactly the same. So we still have this plus 2W. So now we have an equation that we can solve. Let's apply the distributive property. So we have 24 equals, let's see, 2 times 4 is 8, 2 times W is 2W. So we're going to rewrite this as 8 plus 2W plus the 2W that we already had here. So now we're going to combine our like terms. 2W's plus 2W's is really 4W's. So this is really 24 equals 8 plus 4W. Now we can solve it. If you would like to, you can always rewrite this using the commutative property, although it's not necessary. But let's just rewrite what we have up here. 24 equals 8 plus 4w. We want to isolate the variable by eliminating the constant term. So that means that this 8 has to go. This 8 is a constant term. So it has no variable on it. That's why it's called a constant term. So we subtract 8 because we have a positive 8. And we're going to do the same on the other side of our equal sign. We're going to subtract 8. 24 take away 8 is 16. We bring down our equal sign, and we have our 4w on the other side because these eliminate each other. We have to divide by 4 to undo the multiplication by 4. 4 divided by 4 is 1. 1 times w is just w. And 16 divided by 4 is 4, so we end up with w equals 4. So they want us to find the dimensions though. We know the width is 4, but that doesn't tell us what the length is until we use the information that we have up here. So the length is 4 plus whatever the width is. So we know the width is 4, so the length has to be 8. The length is 8 inches. So now we're into what's called basically a rite of passage for algebra. I'm sure you've either heard of or seen people sweat about these train problems. So it really is no big deal. We just have to remember that distance is equal to rate times time. So if we want to find out how far something went, we take the speed that it's going and we multiply by how long it's been going at that speed. So if the first train, it says that it's going 60 miles per hour, then we would have to do for that 60 miles. So the distance for call it train 1 would be 60 miles times how long it's been going. Notice that they ask you in the question here, how long does it take each train to make the trip? So that's our variable. We don't know how long it's going to take. So it's 60 times some unknown amount for train 1. For train 2, its speed is 40 miles per hour. So it's going to be, for train 2, it's going to be 40 times how long it's going to take. But we want to factor in this other information. It's going to travel the same distance in 1.5 hours less time. So that's the passenger train. So I actually need to make a small correction to what I just wrote. So if we take the time that it would take for one train and subtract 1.5 hours, then that would be the distance that it would take for train 1. For train 2, it would just be x. These distances have to be the same. And so we end up with the following equation. 60 times the quantity of x minus 1.5 equals 40x. So we can apply the distributive property to solve this. Or let's be a little bit, let's go ahead and use the distributive property. If we're going to do that though, that 1.5, I want to use something that we did in a previous problem. 1.5 is really the same as 3 halves. $3 split between 2 people is $1.50, or 3 divided by 2 is 1.5. So let's rewrite that as 60 times x minus 3 halves equals 40x. So if we were to apply the distributive property, it would be 60 times x, which would be 60x, and 60 times 3 halves. 60 times 3 halves is really 60 divided by 2, which is 30, times 3, which is 90. You get the same answer if you did 60 times 1.5. So we know we're going to end up with 60x minus 90 equals 40x. So normally we would eliminate the smaller of the two variables, but I know that it's going to create an extra, and we could, but it's going to create an extra step. So in this case, because the 40x is by itself, I could subtract 60x this time from both sides of our equation. When we do, these are going to eliminate, and we're going to be left with negative 90 on the left side of our equation and negative 20x, negative 20x on the right side of our equation. We divide both sides of our equation by negative 20, and we end up with x equals 90 over 20, positive 90 over 20, which we can reduce to 9/2, or 9 over 2. If you want to go the extra step of finding out how much this is in terms of time, it would be about 4.5 hours. So in terms of how long it would take each train, it would take train 2 4.5 hours. But because the freight train, it would take 4.5 hours, but the passenger train takes less time. So we would have to subtract 1.5 hours from the 4.5, and that would be 3. So basically the freight train would take 4.5 hours, and the passenger train would take 3 hours. Alright, so in this case, we want to know or recall what consecutive means. So consecutive means that just that one follows the other. So if we're thinking about consecutive integers, it will be 1, 2, 3, 4, etc. These are consecutive integers. Consecutive even integers would be 2, 4, 6, 8, and so on. Consecutive odd integers would be 1, 3, 5, 7, and so on. So this here says find 3 consecutive. It doesn't say odd, it doesn't say even, so it's just one after the other. Integers whose sum is x plus 1. So if we think about consecutive integers, if we start with some number, x, then we'd have to add 1 to it to get the next one. So 1 plus 1 is 2, and then to get the next one after that, we would have to add another 2. So 1 plus 1 is 2, 1 plus 2 is 3. So those would be our consecutive integers, and then those sum would have to be 126. So we have to add them up to be 126. So x plus the quantity of x plus 1 plus the quantity of x plus 2. And I'm not putting the parentheses because it's not going to make a big difference here, but all of that has to equal to 126. We combine our like terms. We have 1, 2, 3 x's. So x plus x plus x is going to be 3x. And the 1 and the 2 are like terms also. 1 plus 2 is 3. So we have plus 3 equals 126. So now we need to just solve it as we would solve any equation. We subtract 3 from both sides of our equation because of our property of equality. This is 0. 0 plus 3x is 3x. Bring down our equal sign. This is 123. And we divide both sides of our equation by 3. And then we get x here equals 41. So if x is 41, then this is 41 plus 1 is 42. and 41 plus 2 is 43. So those are our consecutive integers. The three of these are going to add up to 126. And you can try that to check it yourself if you'd like to verify that 41 plus 42 plus 43 equals 126. But we know it's true. You can check it yourself though. In this case, we're dealing with odd integers. So exactly how do we represent an odd integer? Well, an odd integer is an even integer plus 1. So if I take any even number, 6, for example, and I add 1 to it, I get 7, which is an odd number. If I get 8 and I add 1 to it, I also get an odd number. So for consecutive, though, we have to kind of think about it a little bit differently as well. So besides the fact that, so if we just summarize what we have here, let's say we start with some random number. To get this even number, basically it's a number times 2. So if we were to express just some integer, 2x has to be an even integer, because no matter what I put for x here, I'm going to end up with an even number. So if I put a 1, 2 times 1 is 2, that's an even number. If I put a 9, 2 times 9 is 18, that's an even number. To make it odd, I have to add 1. So that is just some odd number. So let's think about what the other integers would have to be. It says 4 odd integers, 4 consecutive odd integers. So in terms of our integers, we could have, let's say, odd integers would be like 3, then 5, then 7, etc. Notice that each time we go up an odd integer, that we're really just adding 2. So if we add 2 to any odd integer, then we're going to get another odd integer. So if we have 2x plus 1, we add 2 to that, that gives us 2x plus 3. So that would be our next odd integer. And we need 4 of these, so we add 2 to that, that would be 2x plus 5. We need another one, we add 2 to the end of it, and that would be 2x plus 7. So these 4 represent odd consecutive integers. The sum of these have to be 2x plus 16. So in other words, the quantity 2x plus 1 plus the quantity 2x plus 3 plus the quantity 2x plus 5 plus the quantity 2x plus 7, when we add all 4 of these values, they represent odd integers. When we add them up, their sum has to be equal to 216. When we combine our like terms, 2x plus 2x plus 2x plus 2x gives us 8x. And we add 1 plus 3, that's 4, plus 5 is 9, and 9 plus 7 is 16. So we end up with 8x plus 16 equals 216. So we subtract 16 from both sides of our equation. We end up with 8x equals 200. We divide both sides of our equation by 8. And so x has to be equal to 25. But remember, the objective was to find out what those integers were. So let's go back a few steps. X is 25. So if we did 2 times 25, that's 50. 50 plus 1 is 51. So the first odd integer is 51. We added 2 to that, so that would be 53. We added 2 to that, so the next consecutive odd integer would be 55. Add 2 to that, and that would be 57. So you can check it yourself if the sum of these 4 is 216, but we know this to be true. When we have equations with letters where numbers are supposed to be, in other words, with more than one variable, we can refer to these as literal equations. And actually, literal comes from the Latin litera, which means letter. But in this case, this is a formula. Sometimes, though, well, these formulas are not literal equations, but they're pretty close. To deal with either a formula or a literal equation, and we are trying to get a particular variable by itself, what we're going to do is we're going to pretend like that's the variable and everything else is just a number. So this b right here, we're going to pretend like it's some number like 8 or what have you. So 1/2 times b is what we're trying to eliminate to get this h by itself. So let's say we focus on this a little at a time, and we want to get rid of this 1/2 first. To eliminate a fraction, remember that we have to multiply by its reciprocal. So we're going to multiply this side by the reciprocal of 1/2, which is 2. 2 over 1, or 2. And because of our property of equality, we have to do the same to the other side of our equal sign. So we multiply that side by 2 also. So what are we going to have left? Well, obviously on the left, nothing we can do. It's still going to be 2a. We bring down our equal sign. When we do 2 times 1/2, that's going to be 1. 1 times b is b, and we're still doing b times h. So on that side, we're just going to end up with b times h. So now we need to get the h by itself. If we had, let's say, 2 times h or 3 times h, and we want to get h by itself, we'd have to divide by whatever that number was. So we're going to divide this side by the coefficient, which is b. We're going to divide by b. Our property of equality says that we're going to do the same on the other side of our equal sign as well. B divided by b, just like 5 divided by 5, or 7 divided by 7, or 9 divided by 9, or a million divided by a million, is going to be 1. So this is 1. 1 times h is h. And there's nothing we can do on the other side because we're basically just dealing with a whole bunch of unknowns. And so this is how we would solve for h. H is equal to 2a over b, or 2a divided by b. You're welcome to pause at any time, but let's look at how we would solve for the indicated variable. So in the first one, we want to solve for w. In the second one, we want to solve for L. In the third one, we want to solve for y. And in the fourth one, we want to solve for b. So up here where we're trying to solve for w, w is basically our variable. Everything else is a constant that we want to eliminate. So this 2L has to go. So we're going to subtract 2L from both sides of our equation, and we end up with P minus 2L equals 2W. And we have to divide both sides of our equation by 2. Remember, we can either divide by 2 or multiply by 1/2. We'll end up with the same result. So divide the whole of the other side by 2 as well, and we end up with W equals P minus 2L all over 2. One thing to note is that what we have here, we're basically saying P divided by 2. If we were to write this out based on what we know about fractions, this is equivalent to saying W is equal to P over 2 minus 2L over 2. Working backwards with what we know about subtracting fractions, we know that this that we wrote is equivalent here, because normally what we would do is we would say, okay, the denominators are the same, we're just going to subtract the numerators. So P minus 2L, P minus 2L, denominator is 2, denominator is 2. So this is equivalent to this. We can go a step further, and 2 divided by 2 is 1, and we end up with 1L. So we could rewrite everything as W equals P over 2, or 1/2 times P, take away L, as our solution. So if you need to, remember it's a recording, so you can go back and review the steps carefully. Anything that you got lost on, you might want to ask about in class. In the second problem, we're trying to solve for L. So the W and the H have to go. So we can divide both sides of our equation by W and H, since they represent a constant factor. So the W is going to divide out. W divided by W is 1. H divided by H is 1. So we're just left with the length is equal to volume divided by the width times the height. For the third one, we're solving for y, so the x has to go. So we would subtract 3x from both sides of our equation to isolate the y. And some students would get this, that this is going to eliminate, and we have 4y over here on the left side of our equation. But for whatever reason, some people would subtract the 7 and the 3 and put 4. Remember that the 7 has no variable next to it. The 3 does. These are not alike. If they were like family members, this one would be like a rock star with no last name, and this individual would be someone that does have a last name. They're not in the same family, so we wouldn't put them together, but we would rewrite it as negative 3x plus 7. Means the same thing, because we're subtracting here, and remember that when we're adding and the signs are opposite, we're really subtracting. So we're expressing the same situation but in a different way. So now we want to get the y by itself, either by multiplying both sides of our equation by 1/4 or by dividing both sides of our equation by 4. Remember, it's equivalent. Dividing by 4 is equivalent to multiplying by 1/4. 4 divided by 4 is 1. Y is equal to negative 3/4 x plus 7/4. The explanation for that is really in as to why. If you go back and look at the first example a little bit more carefully, you may see why. But if you don't, that might be something to ask about in tutorials. Regarding the last equation, we're trying to solve for b. So that means the a and the x have to go. So we're subtracting 8x from both sides of our equation first. So these are going to eliminate, giving us 0, and we have by on the left side of our equation, and on the right, negative 8x plus c. And the explanation for that is in number 3. So it's very similar to number 3 that we just did. We're going to divide both sides by the coefficient of y. So we're dividing both sides by b, and we're going to end up with y equals what we have on the right. If we wanted to go a step further, it's equivalent to negative ax over b plus c over b, and the explanation is essentially from what we had looked at before. So you can try these examples yourself based on what we discussed previously, so you can pause it at any time to try it yourself first. Okay, in the first example, we are trying to isolate the x. So we could apply the distributive property first if we want to, but it might be simpler just to divide both sides of our equation by 2. The 2's are going to eliminate, since one is multiplication and the other is division, and we're going to be left with 3m over 2, or 3/2 m on that side, and 4 plus x on the other, or x plus 4. To solve for x, this 4 has to go. So we're going to subtract 4 from both sides of our equation, and that leaves us with 3/2 m minus 4 equals x. For the equation below that, we would try to get t by itself, so the p and the r have to go. Because it's multiplication, we're going to divide both sides of our equation by pr. The p and the p divide out, that's 1. The r's divide out, that's 1. So all we have left on the right side is t. And on the left we have I divided by pr. So let me write that a little bit better here. So I divided by pr is equal to t. For the next one, we're trying to isolate n. So again, we can divide both sides of our equation by 180. These 180s divide out, and we're left with n minus 2, and on the right, s over 180. We need to eliminate the subtract 2 by adding 2 to both sides of our equation. We end up with s over 180 plus 2 equals n. So that is how we would do that one. For the next one, we're trying to solve for m. So we're given m plus k. We're given m plus k over h equals w. We're trying to get m by itself. So we have to get rid of that divide by h by multiplying both sides by h. These are going to eliminate because they're inverse operations, and we're left with m plus k equals wh. W times h, remember, is just wh. Put them together means the same as multiplication. So no operation in between the two variables means that you're multiplying them. So we're going to subtract k from both sides of our equation for inverse operations, as a result of inverse operations, and we're left with m is equal to wh minus k. So solving equations does not have to be a big deal. Just make sure that we do this in a very systematic manner.